We will now continue using our properties of logarithms to either condense an expression, which means writing it as a single log, or if they give us a single log, expand it out using our properties of logarithms. So when I take a look at the first example, when you are condensing, always look for numbers in front first. And if you have numbers in front of those logarithms, then your first step needs to be to put those back as powers of the terms that you're taking the log of. So on the first one, I have a log. I have the product x to the fourth y squared, and then the 3 in front will become the power of 3, and we'll simplify that in just a minute. Then we have plus. Now we have the log of the term 1 divided by x, and the 5 in front will become the power of that particular term. And then we have a minus, and we have a log of a y, and the 3 in front will become the power of the y. Okay, so if we want to go ahead and simplify those powers first before we do anything else, when you have powers of a power, like we do in this first example, you will actually multiply their powers together. So that first particular expression will become the log of x to the 12th, since 4 times 3 is 12, y to the 6th, since 2 times 3 is 6. I can continue on the next log as well. Even with a fraction, you can apply that power to both the top and the bottom. So on top, when I raise 1 to the power of 5, it's still 1. And on bottom, x to the power of 5 would be x to the 5th. And then, of course, the last term, there's nothing to simplify. So next, I'm going to work left to right. When I see that two logarithms are being added, I remember with my properties to put them back together, I will multiply their terms. So I will have a log, and I'm going to multiply x to the 12th, y to the 6th, times the 1 over x to the 5th. And if you want to think about these first terms as being over 1, it helps you see a little bit easier that when you have a fraction of a fraction, you'll actually multiply all the top terms together, simplify that, and then you'll come back and multiply the bottom terms together. And then, of course, we still have the minus the log of y to the 3rd power. So now, as I simplify this first expression, if you have powers of x on top and bottom, look to see where your highest power is, and the 12 on top is bigger than the 5 on bottom. So if we subtract, 12 minus 5 would leave us with x to the 7th on top. And then we still have y to the 6th on top, and then minus this log of y to the 3rd. And so finally, when we have two logarithms that are being subtracted, we put those back together as a fraction. So we will have the log of x to the 7th, y to the 6th goes on top, y to the 3rd goes on bottom, since that logarithm comes after the minus sign. And then finally, if you have the same variable on top and bottom, like we do with the y's here, then you can simplify by subtracting their powers. And so the bigger powers on top, which means the logarithm would, or the variable would stay on top. So we have the log, we have our x to the 7th, and when we subtract 6 minus 3, that's going to leave us with a y to the 3rd on top as well for our final answer there. Okay, on this next example, we're being asked to expand it. So first of all, notice that we have a product. 64 is being multiplied by x to the power of 6. And when we have a product, we will start out by adding the logs of the factors. So we'll have the log base 8 of 64, and we will add the log base 8 of x to the 6th power. Now, they do want us to simplify numerical expressions that we can do without a calculator. So they're assuming that we remember the meanings of logs. And when I look at this very first one, remember, when you're looking at a logarithm, you're saying to yourself, what power of this base would give you this number? So what power of 8 would give me 64? And that answer would be a 2. So that simplifies to be 2. And then, if we have the log of something raised to a power, remember with our properties, we can pull the power to the front. So the 6 would come to the front and leave us with the log base 8 of x. And so they actually have you filling in the boxes. So I wanted to show you what those boxes look like here. So the 2 would go by itself. The 6 goes up front. The 8 is the subscript because it's the base of the log. And your x would go in that box right there. Finally, on this third example, again, they are asking me to expand. And what so many students want to do is they want to get in a hurry and they see that plus sign and they think they can just break apart those terms. But remember, we do not have a property for the log of a sum. We have the property for the log of a product. So what we're actually going to do instead of trying to break apart that sum, you will notice that the terms 15x and 3y, they both have a common factor of 3. So I'm going to factor that out. That would leave me with a 5x plus a y. And what I've just done is I have created a product. And we do have a property that deals with the log of a product. So this one's a little bit tricky because you've got to do that factoring first. Now, how do we handle the log of a product? Well, we take the log of one factor, so the 3 is one factor, and we add the log of the other factor. And the other factor just happens to be the expression 5x plus y. And again, they want you to simplify any numerical expression that can be done without a calculator. So if you think about this logarithm, you're asking yourself what power of the base 3 would give you 3. Well, that answer is a 1. 3 to the first would give me 3. And then here you're just filling in the base is 3 and the expression is 5x plus y for your final answer there.